Good morning, class. Happy Wednesday. Today we are going to continue with sequences and series, focusing today more on geometric sequences. We will take a few minutes to look at the warm-up. This is a reminder of yesterday's topic about getting terms of the sequence using a formula. If you weren't here, you may want to pull a chair up to a classmate who was right there at your table. Please pause the video now and give students 3 to 4 minutes to finish working on these problems. Now that you've had time to work on these problems, let's look at our answers. Here are the first 5 terms of this sequence. We simply replace the n with the term we are looking for. So if you are trying to find the first term, t sub 1, you replace everywhere you see an n with 1. And that tells me that the first term is a 3, and so on. Let's look at number 2. Again, same idea. Let's just pick one of them to make sure that we're on track here. If I want to find the third term, 1, 2, 3, so here's the third term, I would know that this is going to be equal to 6 times 3, because I'm replacing 3 with n. 6 times 3 minus 7 equals 11, so that's how I got that number. In number 3, the notation is just a little bit different because we're given information that the first term is 9. But now the information we get about finding the next term is dependent on the term before. To find the nth term, I look at the term before, the n minus 1 term, and subtract 4 from that. Let's do an example together. To find a sub 2, I'm going to need the a sub 2 minus 1 term, or a1, minus 4. Remember, a sub 1 is just a label. This isn't a mathematical computation for us to do. And we know that a sub 1 is equal to 9. So I can make that substitution, and I get a sub 2 is equal to 9 minus 4 equals 5. So that's how I get my second term. And so on. Number 4 is similar. If you had some confusion about number 3, then you may wish to pause the video again while people take a moment to think through number 4. But if we're okay on it, then let's continue with number 4. And the terms are as follows. Again, let's just pick one to make sure we're clear about how this works. Suppose I want to find the fourth term. Let's see, I think I have a typo here. If this is -1, that should be a -1 right there to match that. Okay, so to get the fourth term, I would need to, sorry, let's not do the fourth term. Let's do the second term. To get the second term, I would need to do 3 times a sub 1 plus 5. Well, let's do the substitution. A sub 1 is given to us, it's -1, and so I can replace that with -1 in the equation. 3 times -1 plus 5 equals 2, and that's how I get my second term, a sub 2. To find the third term, let's just do this one more because I have a feeling this might be a little bit tricky for people. So to find the third term, a sub 3, remember I'm still building off of this basic formula, a sub 3 is equal to 3 times a sub 2, because that's the term before, plus 5. So now let's substitute in. a sub 2, we just found to be 2, so I'm going to substitute for that in the equation. 3 times 2 plus 5 is equal to 11. And that's how I get this term, a sub 3. And so on, to get the other terms. We are going to begin the class today with a quiz from yesterday's homework, much the way we did a homework quiz last week. So at this time, your desk should be clear except for the homework. I know there were a number of you absent yesterday, and so you will need to make note of the homework assignment listed here in order to get those points. While others who were here yesterday take the quiz, you will just sit quietly because this will only last 5 minutes. So you should have something to write with and your quiz on your desk. So when you are finished with your homework, when you're finished with your quiz, just raise your hand and someone will come collect it. So you can pause the video now while students take the quiz. Please remember, students, that you want to keep your eyes on your own paper or risk losing your paper. We'll pause video now and then look at the answers for the quiz when you are completely finished with it. Now that you are finished with the quiz, let's take some time to look at the key for the quiz so that you have that immediate feedback. Again, if you weren't here, you will need to do the homework assignment to get the 5 points that this assignment is worth. So let me give you a moment to check your answers. We will be getting these back. I'll try to get these back to you tomorrow or Friday at the latest, and we'll talk more about them in depth at that time, but I wanted you to have a moment to see the answers. On one like number 3, if you simplified it, that's fine. I wouldn't mark it wrong, but this is the format that matches the formula that we discussed yesterday. And then finally, here's number 4 and 5 for you to look at. Today we are moving on to looking at geometric sequences in a little more detail. We're going to look at how we can go between the formula for a geometric sequence and the term of a geometric sequence. We're also going to learn what this term geometric means is. So the style of today's class is that you will take notes on an example or two, and then there are a few class problems you will work on. And then at the end of that, you will have the opportunity to work on some problems for homework, if you're a fast finisher, that tomorrow's quiz will be based on. Tomorrow's quiz counts like a regular quiz, not just a homework quiz, so it's really important that you prepare. So at this time, you should have your notebooks out. You should have it labeled with Chapter 11.4, Geometric Sequences, and here is our first example. We've talked about the common ratio before, and that is the number r that we multiply by in order to move from one term to the next. So as I look at this problem, I see that to go from -4 to 2, I can multiply times -1/2. Let me put that in black in case that's easier to see. Let's check it and make sure it works for all of these. Times -1/2. That works, and so my r is -1/2. If you prefer to write it in fraction notation, that's fine. Okay, here's another one. Take a moment to look at this and talk to a table mate to see if you can identify what the common ratio is in this problem. What do I multiply to go from one term to the next? Pause if students would like some time to talk about this. This one's a little bit trickier. To go from 12 to 18, I multiply by 1.5 times 1.5. If you're not sure, remember that you can always look at the second term divided by the term before in order to find the ratio. So this simplifies to 9/6, which simplifies to 3/2, which is 1.5. So 1.5 is my common ratio. Again, it's important that we verify that this works between each of the terms, and I can confirm that indeed it does. So that's my r. In these problems, you will be working on the part of the handout that says geometric sequences classwork. You're finding the common ratio and the next two terms of each geometric sequence. I'm going to suggest that 5 minutes should be more than enough time for this, so pause the video until students have had time to work on numbers 1 through 3. Now let's take some time to look at the answers for these. Analyzing the sequence in number 1 may help you see that the ratio, common ratio, is -2. In number 2, it's 1.5, and in number 3, it might not be as obvious to you. So I will remind you that one way to approach it is to divide the second term, a sub 2, by the first term, a sub 1, in order to get the ratio. 5/3 divided by 5/2 may look sort of ugly, but remember this is just equal to 5/3 divided by 5/2 divided by 5/2, which we can solve by inverting and multiplying the second fraction, 2/5, and that is equal to 2/3. So the ratio that we will try is r equals 2/3. Let's look and see if it works. Times 2/3 gives me, well, let's see, 5/2, let's verify it, times 2/3 is equal to 10/6, which reduces to 5/3. So that works. Checking the next one, 5/3 times 2/3 gives me 10/9, which matches what appears for the next term, so I know that that works. So we found it. I leave it to you to verify with a classmate that you're in agreement about the next two terms for each sequence. Let's look at one more idea. When we are trying to find the nth term of a geometric sequence, there's a formula that will be useful. So you should again have your notes out and be prepared to write this. The equation for the nth term of a geometric sequence is this. So let me move this down here if you're still writing that. So the nth term is equal to the first term times the common ratio to the n minus 1. Let's try one together. T sub n is equal to T sub 1. I'm just rewriting this for now because then it helps me to verify things. So when a sub 1 is 0.8, then I know that the T sub nth term is going to be equal to 0.8 times -5 to the n minus 1. So let's just be clear about what we can substitute here and what we can't, because I know sometimes people aren't sure when they're done with these problems. So I'm given information about my starting term, which was T sub 1, so I'm able to replace that in the equation. And I'm also given information about what the ratio is, and so I'm able to replace that. I'm not trying to substitute in here or here because we want to leave this in general form so that I could find any term of the sequence. Pause now if you need more time for students to finish writing. So let's look at another example where you might be given a sequence of numbers and asked to find the nth term of a geometric sequence. In this example, I'm not told explicitly what the common ratio is, and I'm not told explicitly what the first term is, although this is not hard to find from the sequence above. So in this problem, we have to find the first term and the ratio. So I've done some setup here that will help us with that. Remember, none of the information down below was given initially. We're just constructing the equation from the sequence given. The first term is 250, and my ratio, if I can't just see it by looking at it, remember I can divide the second term by the first term, a sub 2 divided by a sub 1, in order to find it. We're working towards this formula, and so now I can substitute in, sorry, that's out of where you can see. Let's put that down there. So now I can substitute in some of the values that I need and come up with my final formula. So when we plug in the values that we've figured out below, this is what happens. So let's see, I've done a little work ahead for us. So T sub n is equal to 250, that was my initial term, times my value of r to the n minus 1. We had a nice thing happen here that the 250 cancels out, and so that just leaves me with 100 to the n minus 1. If that seems confusing to you, remember that you could have thought of this as 250 over n. The 250 and the 250 cancel, so it's like I'm left with 100 over 1, which is just 100 to the n minus first power. We still have a few more examples, which we'll take up in the second video, but for the remainder of this video, you should begin work on the following 3 classwork problems. I'm going to run out of time on my recording length, and so go to video 2 to see the solutions for these worked out. Happy geometric sequence working.